Welcome to the deep dive. Today, we're going to be tackling the mysteries of the Indus River,
Okay.
but not the usual stuff.
Right.
You've sent us some research on something called stable isotopes.
Yes.
Think of it like high-tech detective work using water molecules to trace the river's journey and even uncover secrets of the Himalayas.
Yeah.
We've got excerpts from a scientific paper published in Applied Geochemistry to guide us.
It's fascinating stuff.
Yeah.
These scientists analyzed 96 water samples from all over the basin.
Wow.
The mainstream tributaries, glaciers, even hot springs.
That's pretty comprehensive.
They were looking for clues hidden within the water itself.
Okay, so first things first, what are these stable isotopes? Sounds pretty technical.
It is.
Break it down for us.
Well, imagine each water molecule carrying a unique tag,
Okay.
revealing its origin and journey. Oxygen-18 and deuterium are two key isotopes.
Gotcha.
By analyzing their ratios in each sample,
Okay.
we can trace the water back to its source, whether it be melting glaciers, monsoon rains,
Right.
or even ancient groundwater.
So like a fingerprint for water.
Exactly.
That's pretty cool. What kind of fingerprints did they find in the Indus?
Well, one of the most striking findings is a distinct south to north pattern of oxygen-18 in the river. As you move north, the ratio of oxygen-18 decreases.
Interesting.
It's a gradient of about 1.3 degrees per degree of latitude.
That's a tiny difference, but what does it tell us about the big picture?
It points to two major players feeding the Indus.
Okay.
The westerlies carrying moisture from the Mediterranean,
Wow, all the way from the Mediterranean.
and the Indian summer monsoons.
Right.
These weather systems converge on the Himalayas, bringing rain and snow that melt and feed the river.
I see.
The oxygen-18 gradient shows how these sources contribute to the Indus's flow.
So these isotopes are like tiny time capsules carrying the history of the river's water.
Yeah, you could say that.
That's amazing. Oh, wait, the paper also mentions something called DXS.
Yes.
What's that all about?
D-excess is another clue we can extract from these isotopes.
Okay.
It tells us how much evaporation the water has undergone.
How does that work?
Think of it this way.
Okay.
When water evaporates, the heavier isotopes tend to stay behind.
Huh.
So by measuring D-excess, we can see how much the sun has sipped on the water
Interesting.
before it reached the Indus.
And what does DXS tell us about the Indus?
The study found high excess in many of the Indus tributaries,
Okay.
suggesting a strong connection to the Mediterranean Sea.
So that Mediterranean water really traveled a long way.
It did. The water vapor traveled a long distance, evaporating along the way, before finally falling as rain or snow in the Himalayas.
It's incredible to think that water traveled all the way from the Mediterranean to the Himalayas. But this is more than just tracing water, right?
It is.
The research also connects to the history of the Himalayas themselves.
Absolutely.
Ah.
There's a fascinating relationship between oxygen-18 and elevation.
Okay.
As air rises and cools, it loses heavier isotopes like oxygen-18. This means that precipitation at higher elevations has a lower ratio of oxygen-18.
I see.
By analyzing the oxygen-18 gradient in the Indus Basin and comparing it to data from ancient rock formations,
Okay.
scientists can estimate the height of mountains millions of years ago.
So by studying the water, we can actually learn about the mountains. That's wild. What did they find about the history of the Himalayas?
The study found a specific slope or gradient of -2 kilometers for oxygen-18 in the Indus Basin.
Okay.
This information, combined with other geological data, can help scientists reconstruct how the Himalayas have risen and evolved over millions of years.
Okay, this is all blowing my mind. We've got ancient water journeys, mountain histories, and the research even includes saline lakes.
Yeah.
Why were those included in the study?
These saline lakes might seem out of place.
Yeah.
But they play a fascinating role in the story of the Indus. They have very different isotope ratios compared to the river,
Oh, really?
mostly because of intense evaporation.
Oh, so they're like little evaporation factories. How does that tie into the larger picture of the Indus?
These lakes, while small,
Yeah.
contribute to local moisture recycling.
Uh-huh.
The water evaporates, leaving behind salts and heavier isotopes, and that evaporated moisture can eventually fall back into the system,
Interesting.
either locally or transported by winds to other parts of the basin.
Wow, so many moving parts.
It adds another layer of complexity to the already fascinating story of the Indus River.
It's truly amazing how much we can learn from just a few drops of water.
It is.
We're back and ready to explore how these isotopic insights can shed light on the future of the Indus River, especially with climate change already impacting water resources around the world.
It's a critical issue. The Indus is a lifeline for millions of people across several countries,
Yeah.
supporting agriculture, providing drinking water, and even generating hydropower.
Right.
But climate change is bringing new challenges.
The paper mentioned that understanding the past can help us prepare for the future. How does this research on isotopes play into that?
Well, the Indus River Basin is a dynamic system, constantly responding to changes in temperature, precipitation, and glacial melt.
Okay.
By using isotopes to understand how these processes have shaped the river in the past,
Right.
we gain valuable insights into how it might respond to future climate scenarios.
So it's like having a historical record of the river's behavior written in water molecules, and that helps us predict future changes.
Exactly. For example, as temperatures rise, we anticipate increased glacial melt.
Okay.
This will initially lead to higher river flows,
Makes sense.
but in the long run, as glaciers shrink, the overall water supply could diminish, potentially leading to shortages.
So it's not just about more water, it's about how that water is distributed over time.
Precisely. And stable isotopes provide a powerful tool for understanding these changes. By monitoring these isotopes over time,
Right.
we can track how glacial melt contributions are changing,
Okay.
see how monsoon patterns are shifting, and even monitor the effects of increased evaporation due to rising temperatures.
So it's like having a finger on the pulse of the river system,
Yeah.
allowing us to see how it's responding to climate change in real time.
That's a great way to put it. This continuous monitoring can help us adapt our water management strategies and ensure the long-term sustainability of the Indus River.
This is all incredibly valuable information, but the Indus River Basin spans multiple countries,
Right.
each with its own water needs. How can this research help with those complex political dynamics?
That's one of the most important aspects of this research. The data provides a shared scientific understanding of the river system, which can be crucial for fostering cooperation and avoiding potential conflicts over water resources.
So it's not just about science, it's about using that science to build bridges and ensure equitable water management for everyone who relies on the Indus.
Exactly. The Indus doesn't recognize political boundaries. It's a shared resource, and understanding its complexities is essential for its sustainable future. This research provides a common ground for dialogue and collaboration between countries.
It's amazing how this research connects to so many things, from the history of the Himalayas to the future of international relations. But what are some of the big unknowns that scientists are still working to figure out?
One of the most pressing questions is understanding how climate change will impact the monsoon system.
Yeah, that makes sense. The monsoon is a critical driver of the Indus River's flow,
It is.
and any changes to its intensity or timing could have major consequences for water availability throughout the basin.
Absolutely.
What tools are scientists using to investigate these changes?
Researchers are using a combination of approaches.
Okay.
In addition to continued isotope analysis,
Uh-huh.
they are employing sophisticated climate models, analyzing satellite data, and even studying tree rings to reconstruct past monsoon patterns
Wait, tree rings.
and project how they might change in the future.
How do those fit into the picture?
Well, the width of tree rings can vary from year to year depending on environmental conditions. In regions affected by the monsoon, the amount of rainfall has a direct impact on tree growth. By analyzing tree rings from different locations and time periods,
Okay.
scientists can create a detailed history of monsoon activity going back hundreds or even thousands of years.
So like the water molecules, the trees are holding clues to the past?
Precisely. And by combining these diverse sources of information,
Right.
we can gain a clearer picture of how the Indus River system has been shaped by climate in the past and how it might respond to the challenges of a changing climate in the future.
This has been an incredible deep dive so far. We've explored the sources of the Indus, uncovered secrets of the Himalayas, and even glimpsed into the future of this vital river system. But there's still more to explore. When we return, we'll discuss the broader implications of this research and what it means for water resources around the world. Stay tuned. We're back for the final part of our deep dive into the Indus River. It's amazing how this research has taken us from ancient water journeys to the future of climate change.
Right.
But this isn't just about one river, is it?
Not at all. The Indus provides valuable lessons that can be applied to other river systems around the world,
Okay.
especially those facing similar challenges from climate change and growing populations.
So the Indus is like a case study for understanding how climate change is impacting water resources on a global scale.
Exactly. By studying the Indus, we can develop new strategies for water management that can be adapted and implemented in other regions. It's about sharing knowledge and finding solutions that work in different contexts.
It really highlights how interconnected everything is. The challenges facing one river system can have ripple effects across the globe.
Precisely. And that's why international collaboration and knowledge sharing are so important.
Yeah.
We need to work together to address the complexities of climate change and ensure the sustainability of water resources for everyone.
As we wrap up this deep dive, what's the one key takeaway you want our listeners to remember about the Indus River?
I think the most important message is that the Indus is a dynamic system, intricately connected to climate patterns, glacial melt, and human activities. By understanding these connections, particularly through tools like stable isotope analysis, we can make more informed decisions about how to manage this vital resource for current and future generations.
This deep dive has been an incredible journey, revealing so much about the Indus River. We've explored its ancient origins, the forces shaping its present, and the challenges it faces in the future. But most importantly, we've seen how science can help us understand and protect this vital resource.
And remember, the research continues. As scientists gather more data and refine their models, we'll gain an even deeper understanding of the Indus and what we can do to ensure its health and resilience.
Thanks for joining us on this incredible deep dive into the Indus River. We've learned about the power of isotopes, the history hidden in water molecules, and the importance of collaboration in facing the challenges of climate change. Until next time, keep exploring, keep learning, and keep diving deep into the wonders of our world.